Flack math! Give me some math and I'll give you some flack. Flack math!
Okay, so this week our homework is just problem set 30, and then our practice test and test. I think we're on 5, right? Or 7? 5 or 7?
I think we had 6.
Is it test 6? That's what I put?
6 ones.
Okay, gotcha.
Our last test was test 3B though.
Yeah, so it's, for this class, it's every 4 units, then you do a test. But for others, it's like every 5. It's kind of weird. But anywho, let's do these 2 lessons. So 29 and 30. So this is lesson 29. We're going to talk about negative exponents. Ethan, I'm coming in. I'm going through these markers way faster than that. So, negative exponents. The most important thing that you need to know is negative exponents have nothing to do with whether something's positive or negative. Okay? That's weird. So that's the first thing I want to say so it sticks in your brain. Negative exponents have nothing to do with whether something's positive or negative. Okay? So negative exponents. So what are exponents? Remember, when you have an exponent, that's just like telling you how many times to multiply something. Okay? So if you have a negative exponent, that's kind of like how many times you opposite of multiply something.
Divide?
Yes. So it's kind of like how many times you divide something. So for example, 5 to the negative 2 is not 5 times 5, it's 1 over 5. So it's basically, you're dividing by 5 2 times. So 1 divided by 5 divided by another 5. Okay? The easier way to think about it is when you see a negative exponent, you flip it. Okay? So when you flip it, that goes on the bottom and the exponent becomes positive. Okay? So that's what the negative sign means. Has nothing to do with whether it's positive or negative. So 5 to the negative 2 power is 1/25. Okay? So here's the rule. The rule is x to the negative n equals 1 over x to the n. So any number, it could be a fraction, decimal, whatever. If you have a negative exponent, just throw it on the bottom and make it positive. That's it. It's a pretty simple rule if you can remember it. Okay? All right, so let's do some examples. So I want to write this with a negative exponent. Let's say that I'm on a mission. I never want to see a fraction again. It's an honorable mission. 1 over 3 to the 4th. Let's write that with a negative exponent. How do you write that with a negative exponent? Nathan.
3 to the negative 4th?
That's it. That's it. Okay, good. What about this? 1 over 3 to the negative 3rd. Let's get rid of that fraction. Let's bring that upstairs. What does it become? 3 to the positive 3rd, right. So this goes up top. And you can do that whenever you want, as long as you change the sign of the exponent. Which equals, what is that, 27, right? So far, so good? Okay, what about this? let's just move it. Let's just move on. I think I mixed up my examples here, which is okay. What about this?
Nothing. Still 1 over 3 to the second.
1 over
Negative 3 to the second.
-3 parentheses. So this is 2 steps. Okay? So first, deal with the negative exponent. So that just looks like this. So it looks the same exact way. It's just on the bottom, and it has a positive exponent instead of a negative exponent. Right? See what we did? Okay, well now we can simplify that. What is parenthesis -3 squared? Just 9. So that's just 1/9. Okay? All right, well here's another example 3b. If it was -3, so see the difference between -3, or example 3 and example 3b? There's no parentheses. Well, first things first, let's deal with the negative exponent. What does that exponent apply to? That -2 exponent. What does it apply to? Just the 3. So what do you do with the negative? Well, that doesn't go on the, it doesn't matter if it goes on the bottom or at the top, but no, the only thing that the -2 applies to is that 3. So so we're going to deal with that negative later. So see how that negative is still there on top. Okay, so what is this? -1/9. Okay, good. All right, a few more things. So this, we can still apply our same rules, but this time your answer key or your homework might say, I want you to write your answer with all positive exponents, or they might say, I want you to write your answer without a denominator, with no fractions. Well, we can write this answer in 2 different ways. So first steps, what? What do we do first? What's that? Yeah, I mean, they're not like terms, but I know what you mean. So you're multiplying similar bases, so what do you do with the exponents? You add them, right? So let's do the x's. What do you get when you add 4 and -2? 2. And then m is 2 and -5. Okay, so this is a simplified answer. All right, so this is an answer, but your directions in your homework might say, I want you to write your answer with all positive exponents. Do we have positive exponents? No, so how do you make this positive? You have to switch the floor level, right? So it's on the top floor, you need to put it on the bottom floor. So if you have a negative exponent, you switch the floor level. If it's upstairs, you throw it downstairs. If it's downstairs, you throw it upstairs. Okay? So this would be, or x squared over m cubed. Both of these answers are simplified correct answers. So it's going to depend on what your book says. If it says write your answer without a denominator, then you would write it that first way. If it says write with all positive exponents, you would write it that second way. You see the difference? Okay, but they both mean the same thing. They're both right answers. So if you, on a test, if you give me this and it says, and the direction said write your answer with all positive exponents, so I'd still give you credit for that, because this is the right answer, you just didn't answer the question correctly. Okay. All right, so let's do, the next part of this lesson is 0 exponents. This is kind of a weird one. So let me just show you what's happening. You guys know what 4 to the 0 power is? It's the number 1. It's not 4 to the first power or anything like that. It's just the number 1. That's weird, don't you think? Well, let me show you. So what's the rule if you have like 4 to the 7th over 4 to the 7th? What do you do with the exponents when you're dividing ones with similar bases?
Subtract.
Yep, you subtract. So that equals 4 to the 7 minus 7, which is 4 to the 0, right? Well, look at this. What is that? That's the same thing over the same thing. So that is just 1. So you can justify your why anything to the 0 power is 1. But anything to the 0 power equals 1. Doesn't matter what it is. Okay? Elephant to the 0 power is 1. So, the way you can think about it is it's not how many times you multiply 4. It's not how many times you divide 4. It's if you multiply and divide at the same time, everything cancels and you get 1. Okay? So it's you can kind of think of it like that way, but this is a good explanation. This is a nice rule if you can remember it. Okay? So anything, any variable, any expression, like if you have a big parenthesis a mile long, and then on the outside of the parentheses there's a cute little 0 exponent, then that whole mile long parenthesis, everything just equals 1. That's a nice rule. Okay, so let's just apply this to a few more examples and then we'll move on to lesson 30. Here's example 6. X squared, y to the 5th, y to the negative 2, x to the negative 2. See if you can simplify that. Give me an answer. You can give it to me however you want, either with all positive exponents or as without denominators, doesn't matter. Okay, I'm going to move slowly here. So what you got so far? Okay, so what's x to the 0? 1. So this equals just 1 times y to the 3rd, which is just y to the 3rd. Whenever you multiply 1 by something, it just, that 1 kind of disappears, if it's a multiplication problem. So when this happens, you can just cancel it out. And then you're left with y to the 3rd. Okay? You can only cancel it because it's multiplying by something. So I ran over 1 cat means the same thing as I ran over a cat. You don't need the 1 there. You can just say cat.
I could run over a cat.
I didn't run over a cat. I ran over 3 cats. I'm just kidding. Put him in the nuggetizer. It was very yummy. Sorry, did I say that out loud? think Cheyenne was disturbed by that
I
video.
showed my brother the video and he had a blast. I did not.
You're never gonna go to Chick-fil-A again. Oh no.
Favorite spot too. He's like, "Can we go?"
I'll never
Forget about that.
have a nugget again. Alright, example 7. Let's try this one. Well, this is just a 2-for-1 problem here. If I have x to the 5th, y to the 0, cute little y to the 0. What's y to the 0?
0,
1. This is just a distributive problem, which only means that it's, oh goodness. I can't read my. Okay. So this is just a distributive problem. So we're just going to distribute this to both, right? Well, we can clean this up first before we multiply. What can we do to make this problem simpler? Nathan?
replace the z to 0th power to the y 0th power with 1.
Yep. Or just cross it out. Only because it's 1 times p to the negative third is just p to the negative third. Okay? That one cancels. Anything else cancel? Nope. So now we can distribute. So now instead of distributing these 3 variables, we're just distributing the 2. So x to the 5th z times p to the negative third. Well, that's just p to the negative third x to the 5th z. So far, so good? All right, now let's do the next one. Minus, put that 4 out in front. Then we got x to the 5th times x to the negative 5th. What's x to the 5th times x to the negative 5th?
X 0.
X to the 0, which we really didn't have to write that, did we? We could have just moved on to the z's, which is just z to the 5th, right? Because z times z to the 4th is z to the 5th. So there's our answer. And then we can't do anything else. Does that make sense? Okay, let me show you a very common mistake. This happens a lot. Don't let this happen to you. This is actually going to be on one of your tests. So be careful not to make this classic mistake. All right, x to the negative 2, y to the negative 2 times x squared, y squared plus 4, x to the 4th, y squared. All right, do that on your paper and be cautious. Be cautious.
This is a distributive one.
Yep, distributive because it's this times these 2 terms, right? So we're going to distribute that to both of those. You have an answer? Okay, let's wait a few more seconds. All right, let's try this. What happens when you multiply these two things together? What do you get?
1.
0.
Okay,
Oh, wait, a 1.
good. Now the classic mistake is to just say, oh, those cancel. No, well, they only cancel if it's being multiplied by something else. So this ends up being x to the 0, y to the 0, plus, what is this? 4x squared, y to the 0. Okay, well, yeah, that cancels and this cancels, but if it cancels completely, remember this equals 1. It's 1 times 1. If x to the 0 is 1 and y to the 0 is 1, it's 1 times 1. So unlike up here, we could just cancel these because it's 1 times p to the negative third, which is just p to the negative third. Well, this doesn't cancel to 0. It's not this. This isn't the answer. The answer is 1 plus 4x squared. So that is a very common mistake, is to just cancel that and just multiply these two. Well, no. If everything cancels with 0 exponents, then you still need a 1 there. Okay? Can you remember that? Awesome. All right. Let's move on to lesson 30.
Flack math! Give me some math and I'll give you some flack. Flack